Okay, guys, here I am. I'm ready to teach 5.7 on differentials. Hopefully you have your book out because that will help you. Paper, pencil, calculator might even help, and we're ready to rock and roll. All right, I'm having a bad hair day, so don't make fun of me. All right, we're going to do this on differentials and linear approximations. Differentials are super simple. It's literally like taking the derivative and putting the dx on the other side. That's it. You're going to love this lesson, part of the lesson. The differential of y is dy. And so the differential of y is dy. So dy equals the derivative, f prime of x, times the change of x, which in my words is dy equals the derivative times dx. It's not really times dx, so don't get really upset with that. Just stick a dx on the back of it. Okay? So it's this simple. Keep it simple, right? Okay, y equals x squared plus 3x minus 5. Find the differential. Derive. So you guys all know the derivative of x squared is 2x. Derivative of 3x is 3. Derivative of 5 goes away. You literally put it in parentheses and then put a dx on it. And dy equals that. And that's your answer. And that's all you have to do. And I'm off the chart again. Gracious, you'd think I'd learn how to do this after 3 days. There we go. All right, be ready to go on the second problem. We have 3 of them because the derivatives are now going to get more difficult. They're not going to always be the easy derivatives. You're going to use the multiplication rule, division rule, the square root rule, the whatever rule. So this one is the square root of x squared plus 4. So I changed the square root to a power of a half. So I derive that. So using the power rule, I should have said what rule, but I forgot and just told you. So I'm going to move the 1/2 to the front, times x squared plus 4, on parentheses, take 1 away to the negative 1/2, times the derivative of the inside. Don't forget to clap. Derivative of the inside. That's clapping. Okay, then I have to rewrite that because that's sloppy. You have to make sure you have a numerator and a denominator. So my final is going to be 1 over 2. This x squared plus 4 to the negative 1/2 is now going to be on the denominator. The 2x is on the numerator, but you can cancel out those 2's. So your final answer is just that. X over x squared plus 4 to the half with a dx on the numerator. Make sure it's on the numerator. It is not part of the denominator. And that's what dy is, and that's the differential. Liking this so far? Let's see what lovely problem did I put on the third one. All right. X times e of x. Let me see if I've got this centered for you. Good. I'm doing okay. X times e of x. So we have to derive it by the product rule. Oops, I should have asked you. The first times derivative of the second, what's derivative of e dx is e dx, plus the second e dx times derivative of the first one, parentheses, dx. Now, yes, you still take the e dx out, so you still factor it like you did in derivatives. Okay, so you factor out the e dx, so dy equals e dx times x plus 1 dx. That's it. It's easy. It's fun. It's not even difficult. All right, next step. Not as difficult. This stuff, it's just a matter of you knowing your rules. Oh, which brings me to a thought. On page 407, in a blue box, they review all the derivative rules. So if you have any questions on your derivative rules, you forgot them, they're sitting on their page 407. All right, moving right along. I'm now on example, this is example 3 in the book. I combined example 1 and 2 there. I had to put it on one page, you know. My camera's disconnected. Come on, there we go. All right, here we go. Now it says find dy dx. Now we have a denominator. Don't ask me why, they switch it up. Sometimes they want it, sometimes they won't. This is called differential. This just said find dy dx and dx dy. I can't remember which one I found first, but anyhow, I said derive by the differential, get a dx, and get a dy. Oh, I know why I did it. So here's my problem. Ready? X squared plus y squared plus 2xy squared. Write that down. Now here's the deal. This is why it's together. Every time you derive an x, you put a dx behind it. Every time you derive a y, you put dy behind it. Okay? We'll get to dx dy and dy dx in a minute. But this part is the same as what we did on example 1. All right, I'm ready to derive x squared. I get 2x dx. Watch the purple right now. I tried to do 2 steps at once here because of space. So x squared is 2x dx. Y squared is 2y dy. 2x times y squared. Uh-oh. What rule do I have to use? Product rule. The first, 2x, times the derivative of the second, 2y dy, plus the second, y squared, times derivative of the first, 2 dx. Do you see the purple? Write the purple down. Okay, now, I noticed right away that there was a 2 in all of them, so I took a 2 out of all of them. Get rid of those extra numbers. It has to be in all of them, though, for you to divide that out. You can't just divide it out of 3 out of the 4. That doesn't work. But it was in all of them one time at least, so I divided that out, and I got x dx plus y dy equals 2xy dy plus y squared dx. Okay, now here I said, oopsie did I say, derive my... Then I said get dx or dy on different sides. So it's fine. It's kind of like getting all the y terms on the right and all the x terms on the left. Well, I'm going to get all the dx's on the left, and I'm going to get all the... Nope, so I got all my dx's on the right, and I'm going to get all my dy's on the left. So what I did is I started with this first term. I decided to put the dx's on the right. So I subtract x dx from this side. I subtract from this side. Then it means that the dy's have to be on the left. So I subtract 2xy dy over here and 2xy dy over here. That's in that aqua blue. Then what I come up with is now what's left on the left, all the dy stuff. Y dy minus 2x dy. That's what's left on the left. On the right, I have this stuff. Y squared dx minus x dx. Now, you're just looking at the purple again. That's what I got. Now they want me to divide out the dy and stick it on the outside, and divide out the dx and stick it on the outside. So I did that, because remember, that's the differential part. So this red part is differential. Okay, so now I have y minus 2xy dy equals y squared minus x dx. Now you either have to solve for dy dx or dx dy. It doesn't matter which one's which. If you think about it, if I said 3/4 and 4/3, what are those two fractions to each other? They're reciprocals. So here we go. I decided to divide out the dx term. So I'm going to divide out, I did 2 things at once here, I'm sorry. So I decided to divide out this quantity of y minus 2xy to that side. So that's on that side now. But if I divide out the quantities to the right side, I have to divide out the dx to the other side. So now I have dy dx equals y squared minus x all over y minus 2xy. Then, what did we decide? They're just reciprocals. Dx dy is a reciprocal of dy dx. So I just flipped it and literally flipped it and wrote the other fraction on top of each other. Y minus 2xy over y squared minus x squared. That's dx dy. This half the lesson is super simple. Actually, the whole lesson isn't that difficult. This is easy, much easier than related rates. So if you got related rates, you should get this. All right, enough for my chill pill. I'm going to now go down and switch boards. And here I go. All right, linear approximation. This is nothing more than my old favorite formula, point slope y minus y1 equals m times x minus x1. Okay, so you know Mrs. Reed's favorite formula? Well, this is just a version of my favorite formula. The only thing different, let's look at the purple right now, or whatever color that is they move the y1 onto the other side. So it says y equals. So their form is this, and this is in your page on page 409, is the linear approximation formula. Okay, so they say f of x equals f of x sub 0 that's just y1, plus f prime of x sub 0, that's just the slope, times x minus x sub 0. That's like x minus 1. So they just wrote it in a different format. It's same thing over. Promise you. Easy. Example 4. Find the linear approximation to f of x equals x squared plus 2x near x equals 1. And that's x sub 0. I added the x sub 0. In their lesson part, they don't have that as x sub 0, so you might want to put that as x sub 0. So I put steps. Plug in x1, x equals 1, into the original to find f of x. So I plugged in 1 into that. 1 squared plus 2 times 1 is 3. So f of x is 3. F of x is that part of the formula. Okay, then I said derive, so I had to derive it. So the derivative of x squared is 2x. Derivative of 2x is 2, so I have 2x plus 2 as a derivative. And then you have to plug in x1, x equals 1 into that derivative. So what's 2 times 1 plus 2? Well, that's 4. That's the slope. That's nothing more than the slope. You should know that. The first derivative is the slope. Okay? Then I said put it into the formula. So I'm going to put them into this formula. So I get f of x equals 3 plus 4 times the quantity of x minus 1. 3 was at f of x sub 0. Plus 4, that's the slope, times x minus 1. I do some nice math, and I get what f of x equals 4x minus 1. That's your answer. Now, if you look at the book, they draw pictures. I did not draw pictures. Basically, the original formula was a parabola, and this is a line, and it's literally where the line is tangent to the parabola, and we already did a tangent line to the derivative already, so that's exactly the same thing, literally. All right, now for the challenge. I'm going to put a word problem on. I can't read this, so I'll read it from the book. Or I'll drop my book. A bearing with a spherical shape has a radius of 3 centimeters when it is new. If you don't know what a bearing is, it's like a circular shaped ball. Find the approximate volume of the metal lost after it wears down to a radius of 2.971 centimeters. Oh my gosh, my book is dropping. Okay. I can't have all those pages fall. All right, well, I'm going to close my book for the moment. All right. So hopefully you got that. So this is kind of like related rates. You have to figure out what you need and what you have. So I said, what's the formula? Well, it said for volume. And I just told you a bearing is like a spherical ball, so it's the volume of a sphere. Volume equals 4/3 pi r cubed. What variables do you know? Well, I know the radius is 3, and it said it wears down to the radius of 2.971 centimeters. Well, that means it's a rate if I subtract the 2. If I take 2.971 minus the 3, it's a negative, because it's wearing down, of 0.029 centimeters. So that's like the dRdt. Note, they don't write dRdt. They write the change of r. Anytime you see a triangle, that means like the dRdt or the change of. Just like dy dx was a change of x, this dRdt is a change of r. And in a minute, we're going to change the v to the change of v. All right, so dr equals negative 0.029 centimeters. So then I wrote you need to just derive your formula, which we've already did that in related rates. We put the 3 in the front. 3 times 4/3 pi r squared. Triangle r, which means delta r, which means change of r, is the change of v. The dv dt thing. They don't write dv dt, but if you want to, it won't hurt my feelings. Okay? Then they plug in the numbers. dv dt is 4 times pi times 3 times negative 0.029. You get negative 3.28 centimeters cubed. Why is it cubed? Because it's volume. They don't like to write the word, use the negative, so that what happened? You lost 3.28 centimeters cubed space or area when that ball bearing wore down. Think of it more like as when your tire wears down, you lose the tread on your tire. I think you guys understand that. Okay, here's the deal. Here's your assignment, 5.7, page 411, 1, 3, 5, 7, 11, 15, and I added 23 because it was your board problem. Why did I add it? Because it's on the test, so you need to know it. This one's very similar to the word problem you just did here in example 5, so that's why you need it. Okay, did you guys notice that I put a hangout on? For tomorrow, I have 2 hangouts. One's at 9:30 in the morning and one's at 1 o'clock in the afternoon, I believe I said. Okay, here's the deal. You can go on either one. Now, I don't want all of you going on the afternoon because we could have 60 people on the afternoon. That's a lot of chatter. We won't be able to handle that. You will have too many questions. So if you're up in the morning, you take that advantage. I would say it's probably to your advantage to take the morning. I'm also a morning person. So 2 hangouts to choose from tomorrow. We'll try it. If not, I'll label that you have to come in one or you have to come in the other. 9:30 is for brief calc and 1 o'clock is for brief calc. Guess what? If you want to go to 2, you can. Thanks. Hope you get this tonight. See you in the morning. Bye now.